Welcome everybody. Good morning, ladies and gentlemen. So I'm Pierre Souchay from Criteo, and I'm gonna talk to you about administration of Consul at scale. In this 30 minutes presentation, we'll start with a few numbers about what we are doing. Then we will see how the biggest rules we follow to make it work every day. A few tools we are using in order to make it scale. What are the tools we are using? And finally, we'll see the benefits we have on using Consul the way we use it at your scale. So I'm going to start with a few numbers. So I'm leading the discovery team. Consul has been in use for more than 3 years at Criteo. And we started a dedicated team 6 months ago, which is composed of 5 people. The team is handling the development of the SDK, the various SDK. So we are mainly using JVM, Scala, and Java, C#, Python. We're also developing some tools such as GUIs. We will show you a bit later. We of course handle all the all-call on the whole infrastructure. And we also give advice to other teams in order to properly integrate their services into the Criteo infrastructure. And finally, since we have a very large scale infrastructure, we can contribute a lot to Consul. We are now the first external Consul contributors. So about our infrastructure is composed of more than 35,000 bare metal hosts. It's about 40% of Windows, and the remaining are Linux. It is on 8 data centers, with 2 being Hadoop-only data centers, with around more than 3,000 kind of different services, with around 250,000 instances globally. So Criteo is a large advertiser, so we are receiving around more than 2.5 million requests per second. We've got a very large Hadoop data store with more than 100 petabytes of data, huge Kafka infrastructure as well. And of course, we have also lots of developers, more than 300, meaning that we have to scale our users as well. So within our shop, everything is based on Consul, meaning that the load balancing infrastructure is based on Consul. Our SDK, of course, perform their discovery using Consul. And for the applications not Consul aware, we provide, of course, DNS. And so DNS is used by basic infrastructure tools as well as human. All the services that interact with Consul are either on bare metal system, so Windows bare metal, Linux bare metal, Hadoop as well as Mesos, which is platform as a service, a little bit like Nomad. And of course, we are doing KV for configurations of many tools. So the issue then is that when Criteo is, when Consul is down, of course, the whole Criteo is down. No service can talk to any other service, so it's a big issue. So of course, we have to ensure that it's running 24 hours without interruption every day of the week. So in order to do that, we follow some 5 kind of pillars, some rules. So those are mostly basic rules from DevOps environment, but still, the first rule is, of course, we are automating everything, meaning that every Consul agent within our data center is deployed by Chef. Chef is a configuration management system. You've got lots of them, but we are using historically Chef, and everything is deployed using Chef. The registration of a service within the Consul cluster is handled either by Chef, using some helpers we made, either within Mesos, using a standardized way and fully automatic way. There's no handmade registration within Consul, so everything is standardized and automated fully. Of course, we have many, many services, more than 3,000 kind of different services. So in order to have a kind of order within that, all the registration of the service are protected by SCL. SCL is a mechanism in Consul, and that allow you to protect service registration for a name and to ensure that no one can register itself. So in order to ease the integration of various tools, we developed a simple API that allow you to register an SCL within Consul without asking your team. So anyone in the company can ask, can I register this kind of services? The API ensures that you have no conflict between services, meaning that you cannot take the service of another team. And we deployed lots of code in order to ensure that people can freely add service metadata, a feature we added in Consul starting from Consul 1.2.3, I think. And once a service is deployed in the pre-production, then it goes to production. Finally, in order to reduce the entropy in our system, everything is secure by default, meaning that it's not possible from a workstation to write something in the Consul cluster. So available from Consul 1.4.2, we made a patch in order to protect Consul APIs from being called for something else than reading. This reduced quite a lot the entropy that could be added by humans. The rule number 2 is metrics. We put metrics on everything. The biggest, the most important metric we have is black box monitoring. It's basically a simple tool we are using that perform a simple registration into the Consul cluster and wait for the service to appear within the catalog. When it does, then it counts the time needed to do it and produce metrics. So I'm going to show you this kind of metrics here. So this is the kind of dashboard we have. It allows you to quickly show when something is going on. And since it is performed as a black box system, it means that the registration time is something real that our clients might have. Sorry, j'ai la salle. We also added support for Prometheus within Consul itself. And we're also using that, but it's less likely an issue for us because the most important thing is to have an SLA, which is okay for our customers. So we are doing it as additional on-call alerts, but most of the time, the black box monitoring is responsible for calling the on-call guy and fixing the issue. So those are metrics, however, which are very interesting, such as the propagation time between servers, the number of RPC calls, and so on, but it's not the main way we are using in order to ensure that Consul is really working. And finally, we develop other tools, such as a tool called Consul-Templaterb that allow us to export new kind of metrics. The main kind of metrics we are exposing is the number of changes per second on a given service. That's a very important metric for us because it allows you to guess when something is flapping. It allows us as well to perform lots of optimization. We also provide, of course, information for every service within Criteo about which instances are pathing, warning, critical, and we expose this as Prometheus metrics. It means that it's very easy then to create alerting based on those metrics and to have an automated way of creating alerts for everybody within Criteo. And since those tools are working in the same way as the black box monitoring outside of the Consul server, they reflect real world view of what is happening within the cluster, which is a very important thing to think about. Finally, we have, of course, we are exposing logs, info, and history about what is going on in the cluster. We have lots of users. So being a single point of failure within the whole Criteo is not acceptable for us. We have to provide tools to people in order to let them discover what is going on in the cluster in real time. And we have to be able to expose this data to everybody. It means exposing the current state of Consul, of course, the logs, but also the changes in the past, which is a very valuable information whenever you have an incident on your platform, for instance. And since we developed lots of, we deployed lots of energy understanding how Consul works and how creating new patches, we are always ready to patch, meaning that we are using our own Consul fork based on mainstream, but we are ready to apply patches very, very quickly in less than 2 hours. We are able to deploy those patches into pre-prod, look at the metrics, and then go to prod very seamlessly in less than 2 hours. It was really helpful in case of major incident, and it allows us to really control the changes we are putting on the production because it's a very critical piece of our infrastructure. And we also, of course, try to deploy changes as small as possible so we can quickly revert for any kind of feature whenever this feature might have a negative impact on the performance of the cluster. And finally, we are always looking at what is going on the GitHub of Consul. We are especially looking very carefully and very regularly about all the new issues that are created by all of you. And we look whether those issues inspire us by, okay, I already saw this pattern or something like that. Whether it's a new issue, we also look whether this feature or this issue can impact us. And if it does, we fix it by providing a pull request. So we are doing it all of the time, which allows us to keep in sight what is happening in the Consul community and how we could prevent issues from happening in our own clusters. So now I'm going to show you a few tools we are using within Criteo in order to ease our usage daily. So the first is the UI. So I'm going to show you the real one. Okay, I hope everybody can see it. So this UI shows you all the services registered within a single data center. It allows you to switch to across data center, and it allows you, of course, to have a very quick look at any given service, to filter any kind of instance, to search for tag, to search for critical information, and so on. As you can see, all the information is public, meaning that all the information here is provided by metadata, by service metadata, by tags. We also display the status of the health check. So everything is freely available for everybody and scalable because it's simply static content. So it's very important because everybody within the company has the full knowledge of what is going on in the cluster. You can filter, for instance, for dead instance, and so on, and so on. Oops. Well, Okay, demo effect, yes. So those are the dead instance, for instance. We have also a very interesting feature, which was taking us lots of time as a support team, which was how to expose what happened in the past. So this is provided by the timeline. On the timeline, lets you show for a specific service or all the services, even all the services, all the changes within the infrastructure. For instance, here we can see, oh, I'll check the change and what is the value of the check at that time. It's very precious because it allows you, for instance, to look up at a single host and to filter for it and to get the whole information. Previously, those kind of information were quite hard to get because you had to ask the team, oh, what happened at 11 in the morning or whatever. Now this information is available for everybody for one full week, meaning that everybody is free to investigate what is going on a system. With the metrics, we also are using a lot, as I said previously, the number of change per second on a service. For instance, on this graph, you might see the rate of change of a service which is currently deploying. It's a very precious information because it allows you to see whenever your health check are properly set up in your Consul cluster. It gives you precise information whenever this service is working or not. And having those kind of graph allow you to quickly find for incident or future incident, deployment, or even various optimization to perform. Most of the optimization we contributed to into Consul were linked to improving this number of changes per service, so reducing it basically. So our cluster is less noisy and has more performance. And it's very important when your architecture starts being big. So here is a small example of what we are doing as well. Based on the same system, so Consul-Templaterb, I'll give you the link at the end. We are able very quickly in a few lines of code of Ruby to perform a full introspection of our Consul cluster and to look at all the nodes having given tag, given status or whatever. So it's very, very easy to script it and to create script from it. In this example, I hope you see it clearly. We are checking for all the data centers, all the services, and looking at all the instances of a services having a specific tag, whether this service has a single S check, which is considered by us like a failure regarding the automation we put. So this is a few dozens lines of Ruby, and this is the kind of result it is producing. So basically SSH command that allow you to fix the given instance. It's very important because when you have thousands of nodes, you don't want to fix those nodes manually, especially when you have an incident. So having this kind of way to creating scripts from a description of what is going on in the Consul cluster is really, really important. So in that case, it generated a small shell script of 3 lines giving the exact command line to fix the issue. The big advantage of this is you can call it just once and play it, but you can even automatically call it, and whenever the script, so the result of the script is changing, it's gonna auto-fix the whole system for your whole production. So it's very, very effective to be able to script things like this and discovering everything within your data center. Very, very efficient way. Another, a bit more on the technical side, we are also taking care of customizing our systems. I advise you to have a look to the video of Michael Stewart from Bloomberg, who made a great video at HashiConf, at late HashiConf. He explained lots of parameters they are using, and we actually are using the exact same parameters. So it's very precious information. And we went to having almost the same configuration without having seen his video. So it's really great. It's really informative. I also invite you to read the Consul doc, and especially the architecture side. Most people using Consul think the Consul agent do cache everything on the agent. Most of the time, it's not true, meaning that all the calls end up on a server. It's very informative, for instance, to understand the difference between staleness and not staleness, so this kind of stuff. It's very precious if you have lots of nodes. Another thing to use is another PR we made, which is a pull request we made, which is use discovery maxtel, which allow all the clients by default to use staleness. Staleness is very important because it allows you to scale your Consul cluster not only to the leader, which is the elected server in charge of the infrastructure, but all the Consul server. So it allows you to scale horizontally your infrastructure. And finally, tune TTL, especially for DNS, for the exact same reason. So now let's see what are the impacts of having Consul everywhere in a large infrastructure. The first really interesting stuff is it's a full inversion of control, meaning that usually in an infrastructure, when you want to register a monitoring check or something like that, you have to put everything in a single place, a Git repository, for instance, and to put all your check there. It makes really difficult to track the services without those checks. Garbage collection is also an issue. So it's really hard then to invent new services. So using service metadata, you can publish your data and services can inspect you and can find whether you need monitoring, alerting, and so on and so on. We made a huge effort on allowing people to put service metadata into Consul. So for instance, we automated the whole provisioning of our load balancer. So all the network is automated using Consul. That's a great stuff because it used to be very complicated to have various repositories or something. When something was down, it was very hard to debug. And now we have just one source of truth and everybody can see this source of truth through the various GUIs we implemented. Everything is standardized as well. And since metadata is just string, it's very easy to experiment. You can very easily, for instance, declare your Swagger path to your Swagger definition. Swagger is a way to declare your JSON web services, for instance. And so you can really easily list all the APIs you have in your infrastructure. So you can really easily build new services on top of your discovery. That's a major change in the way of dealing with infrastructure. People declare the stuff and other people consume it. So it's a complete inversion of control regarding to what is currently done in most large infrastructures. Finally, as I said, when Consul is down, nothing works. So either it's working, either it's not, but when it's not, people have the way to automatically find where the issue comes from, meaning that when you have a load balancing issue or something like that, there's no question about who is right, who is wrong. Everything is public. You can see it. So either Consul is working and SLA is working, either something else is broken, but people can debug it by themselves. It used to be lots of pressure on the Consul team. There is far less because people are autonomous in order to manage the issue, including when a service is burning or something like that. They are free to understand and fix it. So the team is not a single point of failure when there are large issues, and it's very important as well. So just to end this presentation with a few questions maybe, I'll give you a short list of open source things we publish. So you've got Consul-Templaterb, so it's basically a clone of Consul-Template, which allow us to create our dynamic but served with static web server UIs for Consul. It also provides a full timeline of what is going on in your data center. For us, for instance, the history is around 4 or 5 days on a large data center. It's very easy to hack. It's a simple Ruby. And you can even debug it live, meaning that you can live change your template and it's going to generate the file accordingly. So it's very efficient. You are very efficient when using those tools. And they are ready for very, very large performance on very large number of instances. So it's very optimized. And we also are opening a small GitHub repository where we are putting slowly our various shell script on tooling we are using daily at Criteo. We are opening it slowly because some paths are hard-coded, so they need a bit more work to being published. But we are gonna publish those in the second GitHub repository. And finally, I already talked about this, but I invite you to have a look to the conference, to the video of Bloomberg regarding their scalability to 20K nodes and beyond. So thank you very much. I think we have a few minutes for questions. So maybe I think it's fine now.
We do have a few minutes for questions, so everyone feel free to give some input into the Q&A section at the bottom of the screen.
Sorry?
The question, so there's the same place that you click share, there's a Q&A box, and if you click that, people will be able to input their questions.
All right.
Yeah.
I think there's no question. I don't see any. Do I?
Let's give people some time. We have about 4 minutes.
No question? Or maybe I can do a very quick. Oh, okay. I can do a very quick demo if you want of maybe the UI. I was too fast actually. It's not my. So just a quick look about what we have, for instance, in the timeline. So all of this data is updated live, meaning that and you can filter into a very large amount of data. It gives you a full history. You can go several days back. You can look, of course. So the UI is not limited to services. You can look at keys, at data, and everything can be filtered very easily. As you can see nodes, and everything is served from static, meaning there's a real interesting performance on this side. I think there's a question, but I can't see it.